This is the video for accelerated geometry on section 16-2. It is divided into 2 days, so day 1 is on solving exponential and logarithmic equations. Your key vocabulary is exponential equation and logarithmic equation. The essential question is, how do you solve exponential and logarithmic equations? An exponential equation is an equation containing one or more expressions that have the variable as an exponent. To solve exponential equations, you're going to try and write them so that the bases are the same. So you want the base here and the base here to be the same, not the exponents, the bases. Because once we know that the bases are the same, then we can say that the exponents have to equal and we can solve for our variable. Sometimes we may need to take the log of both sides. So if we know that two things are equal, then as long as we take the log of the left, then we can also take the log of the right. A logarithmic equation is an equation with a logarithmic expression that contains a variable. You can solve the logarithmic equations by using the properties of logs. So if I have the log of a base of something equals the log using that same base of something different, then these two things have to be the same. Let's look at some examples. So we're going to start with looking at solving exponential equations algebraically. So first thing I'm going to do is look and see if my bases are the same. And in this first one, the left side has a base of 7 and the right side has a base of 7. So since the bases are the same, I can say that x equals 2x minus 3. Subtract the 2x to the other side, so I get negative x equals negative 3. Divide by negative 1, and I find out that x equals 3. On number 2, we have 125 as a base and 25 as a base. Since I can't write 125 with a base of 25, and I can't write 25 with a base of 125, we have to come up with another number that both 125 and 25 can be used in. So if we think about our powers, we know that 125 is 5 to the third, and then we have that to the x, and 25 is 5 squared, and that's to the x plus 1. So now they have the same base, but before we do anything else, let's make sure we distribute this, because the property of an exponent to an exponent says to multiply. So this is really 5 to the 3x equals, distribute that. That's going to give me 5 to the 2x plus 2. So now our bases are both 5, and we can say that 3x has to equal 2x plus 2. Subtract 2x, and we find out that x is 2. Example 3, you have a base of 8 and a base of 8, so all we have to do is set the exponents equal to one another. So 5x equals 3x plus 4. Subtract 3x, that gives me 2x equals 4. Divide by 2, and we get that x equals 2. Whenever we have a fraction, you're going to want to rewrite that fraction using a negative exponent. So 1/2 is really just 2 to the negative first, so that's going to be 4 to the x equals 2 to the negative 1 to the x minus 3. Distribute the negative 1. So 4 to the x equals 2 to the negative x plus 3. Now we want to come up with a common base. I can write 4 using a base of 2 because 4 is just 2 squared. So that tells me 2 to the 2x equals 2 to the negative x plus 3. And since they have the same base now, I can say that 2x has to equal negative x plus 3. Add the x over, that gives me 3x equals 3. Divide by 3, and I find out that x is 1. Let's try one where we have our e as our base. So first thing you want to do, anytime you see the e as your base, is to get whatever e is being raised to by itself. So you want to get this whole thing by itself. So the opposite of multiplication is division. So I'm going to divide both sides by 4. So that tells me e to the 3x minus 5 equals 18. And then from here, we're going to take the natural log of both sides. Because as long as we do the same thing to both sides, we're not changing anything to the problem. So all I did was take the natural log of both sides. Now, if we remember that when we see ln, then that's really has a base of e. So this really is written as ln base e of e to the 3x minus 5. So that goes back to one of our properties for logs that says that that's just going to be equal to the 3x minus 5. So I can now say that 3x minus 5 equals ln of 18. In my calculator, I'm going to type in the natural log of 18, and I get about 2.89. So now I have 3x minus 5 equals 2.89. Add 5 to both sides. 3x equals 7.89. And divide by 3. And I get about 2.63. Let's try another one. So I see that my base here is e, so my goal is to get this whole thing by itself. So the opposite of addition is subtraction, so that gives me 6e to the 0.25x equals 12. Opposite of multiplication is division, so that's e to the 0.25x equals 2. Now I'm going to take the natural log of both sides. Again, this really has an imaginary e right here, so this is just going to be 0.25x equals, I'm going to type the natural log of 2 in my calculator and get about 0.69, and then divide by 0.25, and we get 2.77. Solving equations, you always have to remember to check your answers, because remember, we can't take the log of a negative number. So we have the log base 6 of 2x minus 1 equals negative 1. First thing you want to do is to rewrite the number here of negative 1 using a log base 6. So really this is log base 6 of 2x minus 1 equals, well, how can we get negative 1? If you remember, you have the property that says the log base b of b to the x is just equal to x. So if this is equal to negative 1, think about that as this x over here, which means up here is going to be negative 1. These two bases have to be the same, and that number that's going to go here is already told by the other side. So this is going to be the log base 6 of 6 to the negative 1. Now, since they have the same log and same base, we can say that 2x minus 1 has to equal 6 to the negative 1. So that tells me 2x minus 1 equals 1/6. Add 1 over, so that tells me 2x equals 7/6. And divide by 2. So I get x equals 7/6. twelfths. Now, if I plug this back in into this equation in my calculator, and I have 2 times 7 twelfths minus 1 here, so I do in my calculator, I would type the log of 2 times 7 twelfths minus 1 divided by the log of 6. And when I type this in my calculator, I do indeed get -1. So it works. So there's my answer. Let's try another one. First things first, they have the same base. So I know subtraction means that I can really write this as division. So this is really the log base 4 of 100 divided by x plus 1 equals 1. Again, I need to write this as a log base 4. So this is really just log base 4 of 100 over x plus 1 equals log base 4 of 4 to the first. So now they have the same log base. So I can say that 100 over x plus 1 equals 4 to the first. Well, 4 to the first is just 4. Multiply both sides by x plus 1, so I get 100 equals 4x plus 4. Subtract 4 and divide by 4. And when I check it, in my calculator, I'm going to type the log of 100 divided by the log of 4. And then I'm going to take that answer and I'm going to subtract the log of 24 plus 1, which is 25, divided by the log of 4. And when you type that in your calculator, you do indeed get 1. So 24 works. Let's try another one. You have the log base 12 of x plus the log base 12 of x plus 1 equals 1. So they both have the log base 12s and their addition, so this tells me I can multiply these two. So this is really the log base 12 of x times x plus 1 equals 1. So this is really the log base 12 of x squared plus x. Rewrite this using the log base 12, so this is going to be the log base 12 of x squared plus x equals the log base 12 of 12 to the first. So now I have that x squared plus x has to equal 12 to the first, which is just 12. Get it equal to 0, so that tells me that x squared plus x minus 12 equals 0. And we can factor this to find out what x is. That would be x plus 4 times x minus 3. So this tells me that x equals -4. This tells me that x equals 3. Now, when I go back and check it, as soon as I go to write this out, I have the log of -4 divided by the log of 12. That's the first thing I'm going to have to type in to evaluate this first part right here. Well, I can't take the log of a negative number, so -4 is not going to work. So now I have x equals 3. So I'm going to start with the log of 3 divided by the log of 12 plus, go back to the problem, you have the log of 3 plus 1 divided by the log of 12. And when you take this answer and add this answer, you do indeed get 1. So it works. So x equals 3 is our only solution on this problem. Last example, you have 2 natural log of x plus 2 equals 1. So first thing I'm going to do is get this natural log of x by itself. So I'm going to subtract 2 from both sides. So that gets me 2 natural log of x equals -1. Opposite of multiplication is division. So I have the natural log of x equals -1/2. I can get rid of the natural log by using the base of e. So I can say e to the ln of x. And what I do to one side, I have to do to the other. And remember, there's really a little e right here. And we have that log property that says if you have a base raised to the log of that same base of x, then it's just going to equal x. So since this is really ln with a little e right here, so the base here and the base here are the same, this just leaves me with x. So in my calculator, I'm going to type e raised to the -1/2, and we get roughly 0.61. Now, if we go back and check it, 2 times the natural log of 0.61 plus 2, does that equal 1? When you type this in your calculator, I believe your calculator does this. When you type this in your calculator, you'll get a decimal that's super, super close to 1. Now, because we rounded our x here, you're not going to get exactly 1. So it's okay if your decimal comes out to be slightly off when you check here. It does still work.